Hi there, thank you for tuning in. I'm Michael Fudge, and I'd like to welcome you back to our series on mastering the SQL SELECT statement. In this video, we're going to take an in-depth look at aggregate functions like min, max, sum, count, and average, and we'll explore the group by and having clauses. It ought to be a good one, so let's get into it. All right, in this video, we're going to take a look at the group by and having clauses. Specifically, we'll start by looking at the aggregate functions. We'll look at the many different ways that you can count data and use that count aggregate function. Then we'll discuss group by, how to use it, the secret processing order of group by, where it occurs in the processing of the select statement. And then we'll talk about the having clause and why the having clause exists and how you can use that. All right, here I am once again out in Azure Data Studio, ready to show you what this is all about with aggregate operators and group by and having. Okay, so we're starting out as we usually do with a table here. We're looking at the students table. And maybe you want to know just how many students are in this table. So you can use the count operator for that. Good idea to alias the column. Maybe I won't alias the column to start, just to show you what happens. So this is going to retrieve one row. So unlike the other commands we've learned so far, which return actual rows out of the table, these aggregate operators are what are called reducer functions. They will take several rows and then collapse them down to one or more rows, but not the original rows that are in the table. They are now summarized rows. So you see that there's 31 students in the table, and I might want to alias this column as count of students. Oh, I gotta put underscores in there, Mike. A little off my game this morning, apparently. Good. So, a couple other things. Let's do some of the other aggregate. Maybe you want to find out the smallest, the lowest GPA. So you can say select min student GPA as lowest GPA from students. So someone's got a 1.8. You don't know who they are because, again, this is an aggregate operator. We lost the original rows, and now we have a summary. So let's try to add in, let's see who's got the highest GPA, right? So you might have max student GPA as highest GPA. Got to spell it right. It's not stud net. Looks better. And there we go. So someone's got a 4.0, or there could be several people with a 4.0, and then someone or several people have a 1.8. Those are the min and max. There's also an average, right? You can get an average. Get an average as well. There's different aggregate operators. There's also a sum operator, but we'll get into that in a little bit. Okay? So, this is great. Let's talk about different ways that you can count things. So, I had this example before where I counted students. The first question that someone usually asks when it's dealing with counts is, what's the difference between count star and counting a column? So, up here we have all these different columns in the table, right? So, what's the difference between count wildcard and just counting this column? When you count star, you're counting physical rows in the table. When you count a column, you're counting values in that column that are not null. So I believe we have a null down here, right down here. Student 31 has a null. So if I count the major ID, I'll get 30 because there's 30 major IDs, and then one student does not have a major ID. It's null. So that's the difference between counting a column and counting star, which is counting the entire row. I'll show you that. This is actually a count of students with majors. Okay. So I have 31 students and 30 students with actual majors. Okay. If you count the primary key, it's the same as count star, because the primary key is going to definitely, it doesn't allow nulls. And so therefore it would be the same thing. Or counting any column for that matter that does not have nulls in it. Okay, but it could be circumstantial that it does not have nulls. So you don't want to rely on that. All right, so let's show you another trick. So count distinct student major ID. What does that do? Distinct says only count the different values in a column. So in student major ID, I have, people that are majoring in accounting or people that are majoring in information management. So I want to count each different one of those. So this would be a count of different student majors. So there's lots of different ways that you can count things using the count function, and that's good. So there's 4 different majors. I can check that and verify that by just doing a select distinct student major ID from students. This will give me, there's 4 different majors. 1, 2, 3, 4. Now, null is included when you say select distinct. However, when you count, you're not going to count nulls. Nulls don't get included. The same thing with when you average. It doesn't include nulls in the average. When you min or max, nulls are ignored. Nulls mean no value. Why would they be included in there? They wouldn't. Okay. So let's just label this different ways to count things. Verification that there are 4 different majors. So maybe I want to count of students. I want to count of majors, but only in, only among freshmen. So count of majors, but only among freshmen. First, I get a data set of freshmen. Where student year name is freshman. Make sure that works. Those are all my freshmen. Now I'm going to count the different major IDs here. I want to count distinct, right? I don't want to count the physical rows. I want to count the different ones. And there's the freshmen have 3 different majors. So there's 4 different majors in total, but freshmen have 3 different majors. Okay. Now, why did I show you that last example? I showed that last example to sort of segue into the purpose of group by. It's great to go through and count everything among the entire data set, or count the min, or get the min or max or average among the entire data set. But sometimes you might want to get the lowest GPA among the freshmen, or the highest GPA among the freshmen. So you might want to break them out by student year name rather than filtering on student year name. So for that, we need to use the group by clause. So I'll give you an example. So let's first of all create the data set, then we'll create the query. So this is usually how I like to approach it. So I'm going to say select, and let's just say star from students to start. And I am going to get the student year name and the student GPA. Okay, now that I've got you sort of idea with a clue as to what I want to do, what I'd like to do is, for each freshman, I want to get the average GPA. So I want to say, freshman, here's the average. Sophomore, here's the average. Junior, here's the average, okay? So here's how you do that. I want to take the average student GPA as student average. Now, when I do this and I run it, I'm going to get an error that says it's invalid in the select list because it's not contained in either an aggregate function or the group by clause. This is telling you that you must include a group by, and then you must group by the column that you want to display. And you might wonder why. Let me just run it first, and I'll sort of explain the why. So now what I get is each of the different years. I'm still getting a reduction, right? There was 31 rows. Now there's 5 rows. But what do I have here in my 5 rows? I have freshmen, and then this is the average GPA among all the freshmen. Graduate students, average GPA among the graduate students. Juniors, average GPA among the juniors. Okay? So why do you need to group by if you include the column? Well, when you aggregate, right, you are summarizing the rows. So it doesn't know what operation to perform on student year name as far as a summarization goes. Do I want to minimize that or maximize that or whatever? So because I didn't specify that, it doesn't know what to do. If I put in, like, you know, give me the minimum, if I put in minimum student year name, watch what happens. And then let me turn off the group by. What you get is just one row that says what's the first alphabetically of these year names, freshmen, and then what is the average amongst the entire 31 students. That's not what I wanted. What I wanted to do is say, for each change in student year, give me a different GPA. So in order to trigger that for each change, that's what the group by clause does, is it says, among the data set, collect them by this column, and then apply this aggregate over that collection. Okay. If I leave out this, it still works. You just don't know why you're seeing it. You just don't know what you're seeing and why you're seeing it, right? Why is this a 2.99? What does it mean, right? Is it by eye color? Is it by GPA? Is it by major? Is it by student year name? We don't know. I mean, looking at the code, but looking at the results, you do not. And it's a good practice that your query results should be self-explanatory. You should be able to look at the query results and know what the information means. I don't know what this information means. Now, I could help out by putting that up here. Student average by year. But that still doesn't tell me which student, which year. Is this the freshmen? Is this the seniors? I don't know. Okay, so this is an important thing to understand about writing any query that you write, is that you should want the output of the query to be able to explain itself without the need to look at the code that you used to write the query in the first place. Okay? Anybody should be able to just look at this and understand what it means. And that's important. Okay. So that is group by. So group by allows us to take something out of our data set and say, I would like to organize the data set by that, and then apply this aggregate to that. So likewise, I could continue this on. So let's get, averages are not really that useful without counts as well, I would argue, because you want to know how many. So a better way to represent this report might be count of students in major with average GPA. There's my count, or there's my average, and then I'm going to add the count. We'll just count rows. And I'm going to shape this up a little better. There. So I now know there's 7 freshmen, and their average is 2.9, and there's 3 grad students, and their average is 3.9. So I see that. I know that now. Okay. So that is how group by works. And you can apply any of the aggregate operators to it. Count, count distinct, average, sum, min, max. I can actually include those in here. Maybe I want to get the minimum GPA by year. I can just add that to the existing query. And I can make a full report here. Let's say the maximum student GPA, and this is the student max. I'll throw that in there for good measure. So, you know, someone's got a 4.0 in every category except junior, senior, and sophomore. There's nobody in those 3 years that has a 4.0. So you can answer a lot of questions this way by shaping the data. You can see which year has the highest GPA, which year has the most students. So which year has the lowest GPA? Well, that would be juniors. Which year has the most students? Well, that would be seniors. Which year has the student with the lowest GPA? Which student has among the highest GPAs possible, which year has the lowest GPA? That would be sophomore with a 3.3. Okay, the best GPA among the sophomores, 3.3. Okay, so that sort of gives you an idea about group by. Now you can group by more than one column, so I guess maybe I should talk about that. Maybe you want to get a let me set it up first. Okay. We want to get a group by year and major. And then within that, I want to get an average GPA and a count of GPAs, we'll say. Okay. So I'm going to do it like this. I'm going to say, well, anything that you show in the select line, you have to group by. Anything you group by, you do not have to show in the select line, but it doesn't make a lot of sense to do that. Right? Because you need to see this column and this column in order to understand what the aggregate means. So you should, you don't have to, but you should. So I want to group by student, year, name. It's interesting because this here gets processed before the projection. One of the last things that happens in the select statement is the projection. The projection, then the order by. Everything else sort of happens in the right order, right? First you do from, then you do where, then you do group by, etc. And then you do the projection, and then you do the order by. That's just something you got to get used to with the select statement. So student year name, student major ID, and then because I'm grouping by those, I probably should show them. So that's my start. So I have, you know, freshmen, and then there's 3 majors. Now I might want to know the names of those majors, so let's do a join, right? Join, and let's, for the sake of helping you out, there's majors. And it's major ID and student major ID are what I'm going to join them on. And then I want the major name. So rather than show student major ID, I'm going to show major name. And then I'm going to get major name by using a join. Student major ID is my foreign key. Major ID is my primary key. Just to show you that that's the foreign key in case you didn't remember from a previous video. Student major ID right there. FK. See that? Foreign key, primary key. That's how I'm going to join them. All right. Let's see what we get here. Okay, so now I know freshman accounting, freshman applied data science, freshman information management and technology. I know each of the majors. among the students. Now that I have that figured out, I would like to figure out what the average GPA is. So I can just throw that in here as an aggregate. Now, a great name for this column is not really average GPA. That's kind of a bad name for this column, because once again, it implies that when someone just sees this report, they know that that average GPA is by freshman and by major. Are they going to know that? Maybe, maybe not. It's better to be crystal clear with it and alias the column as average GPA by year and major. That way, everybody knows what we're talking about. Okay. Now, does this mean that every single freshman in here has a 4.0? Yes, but how many are there? We don't know. This is why counts are important to include with averages. Counts are important to include with averages. Now, another thing I don't like is maybe I want all the freshmen first, then all the majors. See how it's sorted it? So I need to include an order by here. An order by student year name first. Grouping by is no guarantee that it's going to sort it either. You need to explicitly include the way you want to sort the query. Okay, now I get, freshman, 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 accounting, applied data science, information management. Okay, now these aren't ordered right, but I'd have to include that other table to do that. I'm not going to do that. Let's do the count. Let's add the count in here. We'll just count rows as average, as count of students, count by year and major. There we go. So, yes, there's a 4.0, but there's only one student in there. Okay. That makes a little more sense. So that's using group by. Pretty slick. Now, let's kick it up one more notch. Maybe you want to let's go back to an example that we did before, just to keep things simple. Let's get an average of GPA by major, okay? And we're going to use this join to do that. So let's say major name, and then average student GPA as average GPA by major. Okay. Now, I'm going to run this, but you know already this is not going to work, right? You're with me on this. It's not going to work because I need to include group by. I cannot aggregate a column and then display a column that isn't an aggregate unless I explicitly tell the select statement to group by this column. Otherwise, it's expecting this to be an aggregate. Min, max, something like that. Again, the order in which it processes is different, right? So first it does this, then last it does this. Second, it's going to do this. So it does this first, makes a big fat table, then it groups them, then it projects them last. And there you go. So we have our major names and then our average GPA by major. Now, a couple things. So this is average GPA by major. So let's talk having. The having clause, let's add counts. Always add counts with averages, Mike. There we go. We added counts. Now, one other thing here is if you add these up, you get 9, right? And 6 is 15, and 15 is 30. We're missing one person. One person doesn't have a major. One person does not have a major. So if we want to include that one student that does not have a major, we need to include all students, even the ones without majors. So we need to put a left here because we want every single student, even those without majors. Now, to make this sort of read a little better, I'm going to put this up there, go like that. Okay, so there's our one student with no major, null. That student has a 4.0, and there's one student that does not have a major. Okay, so now they're all there. The gang's all here. Now let's suppose we want to take this data and show only freshmen. We can use a where clause for that, right? We can just put a where clause right here. You know, where student year name, freshman. You could do that. I argue if you're going to do that, it's a good idea to include freshmen as a column in here so that people know what you're looking at. When you look at this, you don't know, is it freshman? Nothing in here. Again, nothing in here indicates it's just freshman. So you should include that as like so. I got to group by it, and then I have to project it. I really just want to project it, but in order to project it, I need to group by it. Okay, now I see freshman there. Okay? For only freshmen. All right. Okay, that's one thing. Now let's talk having. Let me take freshmen out. This is what we had before. Maybe I want to take this data and only show it when the GPA, the average GPA is bigger than 3. Okay, so I want to take this data and I want to filter what I see so that only the GPAs are larger than 3.0. Okay, so I don't want to see this one and I don't want to see that one in this particular case. You cannot do that with a where clause because the where condition is based on this column, which is an aggregate column. So you need a way to filter the data after you group. This is the purpose of having. Having basically allows you to run what's similar to a where clause. It's just not called where, not called where to, it's called having. And you're filtering the data after you group. So now you might say, oh, cool. Well, now I can say having GPA, having average GPA by major bigger than 3. Boom. Done. Awesome. No, it's not going to work. Why? Again, the way the query gets processed is the select projection occurs last. Last. So it doesn't know about this column alias here. It has no idea what that is. So you actually have to say having and then use the aggregate operator. Having an average student GPA bigger than 3. Now, does that mean it's doing it the average twice because I wrote it twice? Hell no. That's not what's happening here. Okay? It is, in reality, making this column and then filtering that column. It's just that the column alias is not available at that time. This is just one of the weird things that you have to get used to with the select statement. It's one of these legacy baggage things with the SQL select statement. I will say this. When we talk about building table valued expressions with the with statement, you can simplify a lot of your intent with the with statement and make things a little easier to understand. And we'll get to that in another video. And then that way, when you look at this, you don't look at it and say, what is this all about? I don't know. It doesn't make a lot of sense, right? So what in essence we did was we filtered, if I run this, Okay? We filtered out, with this having line, those rows where the major, if you will, was more than 3. Okay? All right, that is min, max, average, all the aggregate functions, group by, and how you use having. The last thing I'll mention is whenever you use having, you should always be filtering an aggregate. There's no point, if you're going to filter an actual row, like if I said where having major name accounting, I can do that in a where clause. So there's no point in doing it in having. And as a matter of fact, you're better served doing it in a where clause, because then that will be less things that you run through these aggregate functions. So you should only be using having when you need to filter based on an aggregate function. Okay, that's the rule of having. That's the general guideline of having.